Hi, welcome to iEducator. This is Teacher Jeff. I'm an educator and an engineer by profession. And today we will discuss Chapter 2. And Chapter 2 is all about summarizing data through descriptive statistics. And in today's lesson, at the end of the session, the learner should be able to construct various types of tables and graphs as means of organizing and presenting the data. Second, they should be able to interpret information contained in tables and graphs. Also, they should be able to evaluate appropriateness of various types of tables and graphs relative to the nature and magnitude of the given data. And finally, we should also be able to calculate numerical measures of summarizing data. And in today's lesson, our topic outline is divided into four parts. First, we have the tabular methods of summarizing data. The second part, that would be the graphic depiction of data. The third part, that would be the describing data with numeric summary values. And finally, we have summary of measures of location. Now, under our first part of our topic outline, it includes frequency distribution table, or the FDT, how to construct frequency distribution table, and also we have age dependency ratio. And for the part 2, graphic depiction of data, we will be discussing about bar graphs, the histograms, and the line graphs, as well as the frequency polygon, the ORGIV or the OGIV or the cumulative frequency polygon, and the pie chart as well. And for our third part of our lesson, that would be describing data with numeric summary values. We will be discussing about numbers, percentages, and proportion as well. And finally, for the last part of our topic, summary measures of location. So these are the central measures of tendency. We have the mean, median, and the mode. Now take note that piles of raw data by themselves may not be informative, but when the data are presented in summary form, they may be much more interesting and meaningful to us, right? Now, there are methods of summarizing data. First, we have the tabular methods. Second, we have the graphical method. And finally, we have the numerical method. And so for that matter, we will discuss the first method of summarizing data, which is the tabular method. So our first key area, that would be, or the first key subtopic rather, that would be the frequency distribution table. So what is meant by frequency distribution table then? If we say frequency distribution table in statistics, it is a tabular method of organizing data where each part of the data is assigned to a corresponding frequency. Now, take note that the most commonly used way to tabulate data is to construct a frequency distribution table by grouping the raw data into categories along with the number of observations falling into each category. And aside from that, a frequency distribution table is one way you can organize data so that it makes more sense. It could give a better picture of your data than a simple list. Now, there are different types of frequency distribution tables depending on the level of measurement, nature, and size of data collected. Now, these include the simple frequency distribution. Second, we have the regular or ungrouped frequency distribution. And finally, we have the grouped frequency distribution. Now, in order for us to better understand each of these types of frequency distribution table, let us discuss them one by one, starting with the simple frequency distribution. Now, what is meant by simple frequency distribution table? If we say simple frequency distribution, it is a table that provides a useful way to present data when the dependent measure is discrete or nominal level variable. Now, as you can see in our sample tabulation, this is a tabulation about the distribution of students in the College of Education by areas of specialization. So in our first column, we have there the major areas. So our major areas identified, we have the area of mathematics, English, social science, biology, physical education, and we also have Filipino. And in our second column, we have the frequency or the count. And the final column, we have the percentage. Okay, now as you can see in our sample tabulation, in each major area, you have their designated number of students or colleges. So for mathematics, you have 20. For English, you have 120. For social science, you have 10. Biology, you have 8. 6 for physical education, and 6 for Filipino as well. And therefore, the overall total of the distribution of students in the College of Education by areas of specialization, that would be 170 students. Okay, now how did we calculate the percentage? Well, very simple. That is why it's called simple frequency distribution, because all you need to do is to get the frequency and then divide it by the total number of frequency. So therefore, for mathematics major area, all you need to do is to get 20 and then divide it by 170. So you get 11.76%. Okay. For English, you have 120 divided by 170 multiplied by 100. So you get 70.59%. And for social science, you have 10 divided by 170 multiplied by 100. So you get 5.90, and so on and so forth. And the percentage total should be 100% as well. Okay, so that is what we call simple frequency distribution. And another type of a frequency distribution table, that would be the regular or ungrouped frequency distribution. So what do we mean by regular or ungrouped frequency distribution? If we say regular or ungrouped frequency distribution, it is actually used when there are a small number of observations. In fact, it is merely a tabular arrangement of data that shows the frequency occurrence of the different values of the variables. And usually, the arrangement is in descending order of magnitude. So from highest to lowest number, okay? So as you can see on the sample tabulation, in our table number 2, it illustrates an ungrouped frequency distribution of the number of children per family of 25 randomly selected families in Barangay Paho, Lapu-Lapu City. So as you can see on our tabulation, we have there 2 columns. The first column is allocated for the number of children. And for the second column, you have frequency. So in this case, so in the first column, number of children, you have there 7 or more. Okay, 7 or more number of children per family. So for 7 or more, there are 3 frequencies or counts. For 6, you have 1. 5, you have 2. For 4, you have 5. 3, you have 4. 2, you have 5. 1, you have 3. And 0, you have 2. So for a total of 25. And so for that matter, this is called regular or ungrouped frequency distribution, because what we are doing here is just simply using this data when there are a small number of observations. And the last type of frequency distribution table is what we call grouped frequency distribution. So what do we mean by grouped frequency distribution then? If we say grouped frequency distribution table, It is used when there are so many values of the variable being analyzed, okay? So presentation of data is improved by grouping the values of the variables into non-overlapping or mutually exclusive categories. Now, in order for us to better understand how to construct a grouped frequency distribution table, let us discuss first what a raw data is. Now, as you can see, if we see raw data, these are data in its original form and structure. So for example, the following final exam scores of 40 students are considered as raw data. So as you can see there, these are random numbers. These are not arranged either in descending or ascending order. So meaning to say, these are called raw data. And on the other hand, we have what we call array. So when these scores, okay, when the scores in the previous slides are arranged either in ascending or descending magnitude, then such an arrangement is called an array. So it is usually helpful to put the raw data in an array because it is easy to identify the extreme values or the values where the scores most cluster. So when these data are placed into a system wherein they are organized, then these partake the nature of grouped data. So this procedure of organizing data into groups is called a frequency distribution table. So for example, so as you can see there in our sample frequency distribution table, on our first column, you have their scores, and second, you have the frequency. So as you can see, for those who got a score from 10 to 19, there are 5 students. And there are 4 students who got a score of 20 to 29, 3 students for 30 to 39, 2 students for 40 to 49, and only 1 student who got a score of 50 to 59. Now, the following are the basic components of a frequency distribution table. So it is of paramount importance that we need to understand these basic components of a frequency distribution table because this will help guide us in the construction of a frequency distribution table. So let us start by discussing what a class interval is. Now, if we say class interval, these are the numbers defining your class, okay? Aside from that, these also consist of the end numbers called the class limits. And take note, your class limits are divided into 2. We have the upper class limit or the UCL and the lower class limit or the LCL. Aside from class interval, we also have what we call class frequency, which is denoted by small letter f. And our class frequency shows the number of observations falling into a particular class. And aside from class frequency and interval, we also have class size. If we say class size, this is the difference between 2 consecutive upper limits or 2 consecutive lower limits. So that refers to our class size. Don't you worry, because I will be showing that later on in order for us to better understand and identify what a class size is. And aside from that, we also have what we call class boundaries. And class boundaries, these are the so-called class limits. And also, this is classified into 2. We have the LCB or lower class boundary, and we also have the UCB or upper class boundary. Now, what's the difference between the 2? If we say LCB or lower class boundary, it is the middle value of the lower class limit of the class and the upper class limit of the preceding class. On the other hand, if we say upper class boundary, it is the middle value between the upper class limit of the class and the lower limit of the next class. Take note that if we say the middle value, it's the midpoint or the average or the mean, okay, if that makes sense. And also we have what we call class mark. If I say class mark, this is the midpoint or the middle value of your class interval. And if we say cumulative frequency, it shows the accumulated frequencies of the successive classes. And this is divided into two types. First, we have the greater than CF or greater than CF. And also we have the less than CF. If we say greater than CF, it shows the number of observations greater than LCB or lower class boundary. On the other hand, for less than CF, it shows the number of observations less than your upper class boundary. Now, in order for us to better understand how to construct a frequency or a grouped frequency distribution table, let me give you an example. So as you can see there in our example, you have there 1, 2, 3, 4, 5, 6, 7 columns. Your first column is designated for your class interval. Second, you have your frequency. Third, you have your LCB. Fourth, you have your UCB. Fifth, for your class mark. Sixth, your less than CF. And the last column, that would be your greater than CF. Now, how do we construct your frequency distribution table? Okay, now in constructing your frequency distribution table, so as you can see there, the one encircled, that refers to your LCL or lower class limit. Okay. The other hand, that is your upper class limit of the class. Okay. Again, the 10 is your lower class limit of the class, and the 19 is the upper class limit of your class. All right. And for the 10 and 20, that's our class size. Again, what's a class size again? As we defined earlier, class size is the difference between two consecutive upper limits or two consecutive lower limits. Now, since 10 and 20 are two consecutive lower limits, so this refers to our class size. And also the 19 and 20, these are two consecutive upper limits. So these refer to our class size as well. And as you can see, boxed in red, this refers to our class, okay? So this is our class. So 20, our class is having a class interval of 20 to 29 and a frequency of 4. Okay, now encircled in blue, you have there 19 and 20, because what we are going to be doing right now is to calculate or to get the value of our LCB or lower class boundary. Now, as you can see, okay, now before we calculate or to get the value of our lower class boundary, as we defined earlier, if we say lower class boundary, it is defined as the middle value of the lower class limit of the class and the upper class limit of the preceding class. Now take note, 20 is your lower class limit of your class, okay? And 19 is your upper class limit of your preceding class. So meaning to say, in order to get the value of LCB, all you need to do is to get the midpoint or the average. So you have there 20 plus 19 divided by 2. So therefore, your LCB for your class 20 to 29 with a frequency of 4, that would be 19.5. Okay. For the second class, you have there 30 plus 29 divided by 2. So that's going to be 29.5. For the next class, you have 40 plus 39 divided by 2. You have there 39.5. And for the last class, you have there 50 plus 49 divided by 2. So you have there 49.5. So that's how you calculate your lower class boundary. Okay. Now, what about, sir, what is the lower class boundary of the first class? Okay. The class interval 10 to 19. Now, take note that there is an imaginary class interval there. So what's the preceding class interval? before 10 to 19. So we have there 0 to 9. So therefore, in order to get the value of the LCB of your of your first class interval, so that's gonna be 10 plus 9 divided by 2. So that's gonna be 9.5. Okay. So now that we have calculated, or now that we have gotten the value of your LCB, the next thing that we need to do is to get the value of your upper class boundary. What's an upper class boundary again? Well, as defined earlier, it is the middle value between the upper class limit of the class and the lower limit of the next class. Now, as you can see, 19 is your upper class limit of the class, okay? So our class is the one boxed in red, okay? Take note. Now, 19, again, is your upper class limit of the class, and 20 is your lower class limit of the class. So therefore, in calculating the UCB of the first class, so you have there 19 plus 20 divided by 2, so that's 19.5. For the second class, you have there 29 plus 30 divided by 2, you have 29.5. For the next class, you have 39 plus 40 divided by 2, so you have there 39.5. Next, you have 49 plus 50 divided by 2, so you have 49.5. And finally, you have 59 plus 60 all over 2, so you have there 59.5. So that's how you calculate UCB, or upper class boundary. Now, since we have calculated or gotten the value of your UCB, the next thing that we need to do is to get the class mark. So what's a class mark again? As defined earlier, class mark is your midpoint, or the middle value of your class interval. Now, take note that our class intervals are, you have 10 to 19, 20 to 29, 30 to 39, 40 to 49, and 50 to 59. Now, in order to get the class mark of our first interval, all we need to do is to add the two values and then divide it by 2. So you have then 10 plus 19 divided by 2. So therefore, your class mark for your first class, that would be 14.5. Followed by 20 plus 29 all over 2. So your class mark, that would be 24.5, and so on and so forth, okay? So that's how you calculate your class mark. And the next thing that we need to do is to get the value of our less than CF. And again, as mentioned earlier, your less than CF is, it shows the number of observations less than UCB. So what is our less than CF for the first class then? So as you can see there, you have there 5 frequency. So all you need to do is to copy that number in your first value for your less than CF. And then after that, after copying, all you need to do is to add 5 with 4. So you have 9. And then 9 plus 3, you have 12. 12 plus 2, you have 14. And then 14 plus 1, you have 15. So that's how you get the value of your less than CF. And what about what about getting the value of your greater than CF? Well, in getting the value of greater than CF, so as you can see there, you have 15, right? So all you need to do is to copy that in your first class interval, okay? That will be your greater than CF for your first class interval. And then the next thing you need to do is to deduct 15 by 5. So you get 10. And then 10 minus 4, you have 6. And then 6 minus 3, you have 3. 3 minus 2, you have 1. Okay, so that's how you calculate or get the value of your greater than CF. Okay, so that means to say that we have already completed our frequency distribution table. So that's how you generate or create or construct a frequency distribution table. Now, how to construct a frequency distribution table then, especially if you are given a certain problem? Well, actually, there are certain steps. So it's a step-by-step process that we need to strictly follow. So in order to construct a frequency distribution table, the first step that we need to do is to approximate the number of classes that is denoted by capital letter K using the Sturges approximation formula. And the formula for Sturges approximation, that would be K equals 1 plus 3.322 log n, okay? Where n refers to the total number of observations. So if you are given a particular number, so all you need to do is to plug in the value of your total number of your observations to your n. Okay, that's how you calculate your K. And for the second step, you need to compute the range. So how do you do that? So in your given problem, okay, in your given raw data, if you're given raw data, let's say 30 raw data, okay, so 30 raw data, and this data refer to the height of the basketball players, okay? So all you need to do is to get the highest value or the highest height minus the lowest value or the lowest height of the basketball player. And that's how you calculate or compute the range. And finally, the third step is to compute the class width. And in order to do that, all you need to do is to have your range divided by your K. Okay, so this is how we construct a frequency distribution table. Okay, in order to apply our formula, let me give you an example. So for example, the following data gives the height in inches of a random sample of 30 basketball players. Okay, so you have their raw data. Again, what's step one? Step one is to approximate the number of classes, or K, using the Sturges approximation formula. So you have their K equals 1 plus 3.322 log 30, because our number of observation is 30. We have 30 basketball players. So therefore, our K is equal to 5.91. So approximately that is 6. Okay, so our K is 6. And for R, or our range, as you can notice, our highest value in our raw data is 86 minus the lowest value of 72. And therefore, our range is 14. And for our C, or class width, all we need to do is to get 14 divided by 6. And therefore, our class width is 3. All right, so that's how you do frequency distribution table. All right, I think that's a good place to stop. If you like this video, please don't forget to subscribe and hit the bell button for the latest updates. Thank you.